the slides. So if you want to access slides, so you can scan this QR code or you can type this link. So these slides are going to be on your site as well. So join our community. That is the best way to keep the conversation with us at Voxel 51. So we have here, we are in Zoom, so we have the Q&A widget where you can ask any questions at any time. But also, you can use the chat to interact with each other. It's okay. But something that you need to understand is the chat is private. And for that reason, after the workshop, we cannot see this chat anymore. So if you find any interesting links or you want to keep this conversation with us, please join our community and we can continue the conversation in our Discord channel. So something that I really want to know from you today is, are you familiar with 51? Do you know about 51 something? If you are familiar, just please type 51 in the chat widget. If you are not familiar with 51, just type 50. So, and I can see, okay, I can see a lot of, a lot of 50s, okay. A lot of 51s as well. Nice. Okay. So today we will have a taste for those that are already familiar with 51. We can see some new capabilities that we have, something that we haven't showed before in a Getting Started workshop. And for the ones that are not familiar, I will be sure that you have the solid foundation to work on your side with this content to improve the dataset quality. So something that really important today is, let me see, is the host. I'm Paula Ramos. I need to introduce myself. I always forgot that. So I'm a senior computer vision advocate lead at Voxel 51. And today I'm super excited to have you all here. And we can dive into this fascinating intersection between visual AI and healthcare. Over the past couple of months, I have learned so much about how visual AI can really transform the healthcare industry and help professionals in the field, solving multiple problems. At Voxel 51, we are always engaging with new challenges and collaborating with, different researchers in conferences, helping them to bring innovative solutions to life. So I also, I love to have this interaction with all of you. Let me know, where are you connecting from and what kind of computer vision or machine learning projects or field are you working with? Primarily my background is in computer vision. I have a PhD in computer vision. I have a lot of experience with the visual AI in agriculture, but I'm so passionate about healthcare. It's one of my passions. This is my ice-breaking exercise. So perfect. It seems that the people is a little bit quiet in the chat. It's okay. We can break the ice. Friends, okay, industry images, thank you. That's great to have you here, friends. So if we have people from Europe, South America, Africa, we can see a lot of people in these kind of events. Okay, I will read the chat in a bit, but let me talk about a little bit of myself and why I'm doing this today. So, when I was a child, my dad, who was a doctor, inspired me with his dedication to caring for others. Watching him taking care of the family, friends, and even strangers left a lasting impression of me, and that's part of the reasons I'm so passionate about today's workshop. Something that nobody knows is I wanted to be a doctor, and then I made the decision to move to the engineering world. So this is, part of my story. I can now read the chat and say that we have people from Greece, USA, Spain. Okay, this is great because in Spain we have a great engagement with a lot of events in Espanol. And also we have a lot of presence in Europe as well with a lot of meetups that we are doing. Great, perfect, thank you. So this is part of my story, right? So, but now we are facing a lot of challenges. No, we are facing too many challenges in healthcare. So, and I think that the most significant challenge that we are facing is that we are expecting to see a shortage of over 10 million healthcare workers, globally, by 2030. So this shortage, combined with rising costs and accessibility issue, means that many people, especially in underserved areas, struggle to get care, that the care that they need. So, and we have main three challenges that we have. We're talking about rising costs. Imagine that right now, creating a new drug and put that on the market can cost up to $3 billion, and the doctor shortage that I already mentioned, and the time-intensive nature of the healthcare, where a doctor needs to spend a lot of time on each patient encounter. So, but the good news that we have is visual AI steps in as a potential solution, and it can make diagnosis faster, more accurate, support doctors in their decision making, and even extend healthcare to remote areas through telemedicine or even AI powered tools. So, and AI in healthcare is not brand new. So we have seen this evolution, for a while, since 1970s and 80s, when we can see the early days of medical imaging, to today's deep learning and telemedicine solutions that we can see foundation models, we can see CAD systems era as well. We have a lot of things with CLIP, MedSAM, Med-Gemma, and all. And something that is also remarkable, in 2024, the world celebrated a groundbreaking achievement when Demis Hassibis and John Jumper from Google DeepMind won the Nobel Prize for their contributions to AI. So this moment underscore how AI is revolutionizing healthcare and medicine. We also honor pioneers like Geoffrey Hinton and John Huffield, whose foundation work paved the way for today's AI breakthroughs. So, as we explore this world of visual AI in healthcare, it is incredible to see how these advancements are transforming diagnosis, treatment, and our understanding of disease. Just like the Nobel Prizes winners, we, all of us, on this journey to use AI, we are unlocking the possibility to improve the patient care. So, if you are curious to learn more about what is it right now on the horizon for AI in healthcare, feel free to scan this QR code to check out one of my latest blogs on the topic. That will be really good, and let me know what do you think about that, and that will be great to read your comments. Okay, so when we have a lot of advancements in the field, we can also face new challenges. So right now we are facing visual AI challenges in healthcare. And one of the biggest one is the data sourcing. So getting the right data and making sure that data is well structured can be quite a puzzle. Another challenge that, sometimes is that there is hesitation from doctors when it comes to adopting new AI tools. And there is also a lot of competition in the healthcare industry, especially in places like the US, where healthcare is a huge part of the economy. But good news, so we have a lot of challenges, but good news is that improving the quality of our data sets, we can help overcome these challenges. And that is where tools like 51 come in. So, and for example, if we have unsafe predictions, we have domain shifts, poor quality, or underrepresentation in data, we can find solutions like visual error analysis, image quality filtering, and stratify evaluation. And we can find those solutions and provide those solutions with 51. So let's dive into how you can use 51 to organize and centralize all the complex metadata, this crazy doctor in the image, and how you can, how it 51 can help you piece together the puzzle of your data to find what is missing and how you can improve the overall quality of your data sets. So let me jump to a short demo to showcase how 51 can support this. So 51 is an SDK, but it's also an application. You know, we have a GUI as well. So we have this example with the deep lesion flow with a data set, large scale data set that is called deep lesion, where we can look at this data set that consists in CT scans, and we can see that this comes with a lot of metadata. So you can see in this part of the app that we have a lot of metadata. This includes patient's ID, lesion types, pixel spacing, age, lesion diameters, you know, and more. And it can be overwhelming, but 51 helps us centralize and structure all this data. So we can use the GUI to, for example, select the gender. I want to see if we have males here, you know, and I can also take a look of the labels that I have. I can also see the age of the patient. I can also see the study index. I can also see the patient index as well. We are right now in the era that we don't need to have this in a directory tree. We could have unstructured data, and adding more data, we can see this, the beauty of our data set, and having this centralized is really good. So we have this, this way to filter the data set with, you know, selecting some fields here in the metadata. So for example, let's take a look of the lesion type. We have here different kind of lesion types. When one is related with bones, and we can see just here we have 247 samples in this data set related with bones, males in that specific age. If I click over here, I can see the sample and I can see the lesion, you know. But it's not just that. It's not just navigating the data set with a lot of, you know, exposing the metadata and selecting and filtering that. We can also navigate this in a different way. So we can open the dashboard. And for example, I can also take a look of a numerical histogram, and I want to add, for example, the edge. And I want to use the edge information that I have in the metadata. I can make this interactively updated with the view, or I can keep this for the whole data set. So let me show you this. This is interactive. What this means that if I open this and I click in this bar, for example, I can see all the patients that are in between 40 and 60 in this bar. So I can add more plots and create another kind of filtering. So we can also understand our data set in this way. So another thing that is really nice is that we have also the embeddings. So where we have another panel, interactive panel when we can color this by, let's see, continue with gender. And we can see, you know, what kind, we have maybe a balanced information in gender. We can see maybe outliners here in the embeddings. You know, I can also cover this area and see what this means. Maybe this is an outliner that I need to be aware of, or what is happening here. So, and this is really important also to keep the human and the expert in the loop, because they will provide us what is going on with this kind of information that is a little bit strange for the data set, or is something that I need to add to my training and I don't have. So this kind of information is really important. So we are supporting different kind of visual data, images, videos, 3D point clouds. This is another example that we have. For example, here, and we have this ARI. So basically, we are taking a look of the heart, the coronary ways here. And we are also selecting, different kind of segmentation. We have more than 26 classes in this data set, but something that is really important is how we can understand this stuff. So we need to have the human in the loop, the expert as well. But let's take a look of something that is really cool. I can open and I can see the patches. And I can also calculate the embed. Let me just select here, for example, one label that is stenosis. So I have just stenosis here, and I can open the embeddings, and I can see the embeddings for those specific patches. So what I'm showing here is not just embeddings to general views of the images, also all these segmentations or detections that we have and we need to understand. We can color this, for example, with bounding boxes to see the sizes, and I can select here maybe one specific areas or sizes of the bounding boxes, and maybe understand that we have maybe some orientations, or if we need to be focused on these specific shapes in the stenosis. So this is one example, and maybe you have right now a taste about what 51 is. So I want to double check if we have any questions done in the Q&A widget.
We're all good right now.
Okay, perfect. Thank you. Awesome. So let's move forward with this. So right now, we have the way to work with 51 to improve and understand the data sets that we have. But it's not just the way that we are organizing the data set or we are improving the data set quality. It's also the way that we can also understand the predictions that we have, and we can also understand how the model is working and the behavior of the model and the performance of the model in these cases. So what are our goals today? So the idea today is that we want to understand how 51 makes computer vision project better. This is something that we really want to do. We want to have a hands-on experience with 51 open source, and this is something that we are enabling you to continue working with a solid foundation to go for and explore with your data set, with the data set that you have right now in your system. So let's see that we have now the way. Remember that we have multiple challenges. So we are facing in healthcare multiple challenges, including data quality, bias, explainability, integration, evaluation, maintenance, modality. So these challenges highlight the need for better data set solutions, and that is where 51 comes in. And in the past, many of us have focused on model-centric approach. What that means that we were collecting data, we trained the model, and we deployed that. But often overlook critical edge cases, and we have a lot of data quality issues. So if you think about this can lead to persist bias, increase in model complexity, and higher computational cost. And in fact, this is a reality. 80% of AI projects fail in production because we have these data quality issues, and we are also struggling because the machine learning teams waste a lot of time just rolling data. It's too hard, the amount of time that they are using to understand these problems with the data set. And also we have a significant portion of the model's errors that can be traced back to poor data quality. And just have that in mind. And this is why we need to build better models. And this is essential for AI success. And this is not just for having better models, is what we need to do is we need to improve the data sets. So what 51 is, so 51 is the only open source data-centric AI solution. So we have, we can curate, analyze, and visualize data sets with streamlined annotation workflows, tools, and tools to find and fix labeling mistakes, and the availability to identify and correct model failures. So 51 makes working with visual AI not only possible, but efficient and effective. So this is making visual AI a reality. So 51 covers multiple computer vision tasks. So we have multiple computer vision tasks. So we have classification, detection, instant segmentation, semantic segmentation, polygons, polylines, key points. And also we are supporting multiple visual AI format as image, video, and 3D data. So the role that 51 has in this data-centric AI approach, because remember that this is the only data-centric AI open source solution, is that the platform really shines when it comes to improve data quality, comparing models, and streamlining annotations. With 51, you can load, you can filter data sets, you can visualize embeddings to understand the structure of your data, and you can compare different models to see which one performs the best. And also integrates easily with other tools, so making it a comprehensive solution for your data set. So when you think about the journey, when you have this journey from data to production, so 51 helps at every step. It lets you load and your data, analyze its quality, helping you spot outliers and unique aspect of your data set. This way, you can catch labeling mistakes or model errors before they become bigger or they could hit the modeling production. So essentially, 51 provides a clear view of your data from its raw form through annotations and all the way to model predictions. So this is super important that we are covering tools to evaluate the data in multiple stages when we have raw data, annotations, and model predictions. So we are, with that, we need to be sure that your data sets are as robust, as reliable as possible. So this is part of our goal. So let's start with the hands-on experience. So remember that you can drop your questions in the Q&A widget. So now I can see one question. Yes, we have the recording and the slides. You will receive tomorrow an email with the recording. Okay, this is great because you can continue working on this. So okay, let's move forward. So you can scan this QR code and access this repository. So let me check if I can open this. I can show you what we are doing. So we will navigate these notebooks. I need your attention. You can run this on your side later. For that reason, you will have the recording, and I need your attention, and you can understand how this is working. So we will be focused on that. And please, if you have any questions at any time, drop those in the Q&A widget. So we will navigate these 8 notebooks. In some of them, we will be like a deeper navigation. In some of them, we will show the result in the app. But basically, you have the way to come back to this repository and run this on your side. Even better, if you already have a data set that you want to include, you can change the data set that I'm also putting together here. Okay, so what we want to do, we want to have a hands-on experience with 51. We want to understand how the data sets are managing in 51, how we can curate and filter the data sets, how we can explore embeddings, how we can evaluate and improve models. We also talk about advanced integrations that 51 has, as a lot of flexibility that we have in 51, and also a complex AI pipelines and the latest AI trends that we have implemented in 51. So let's jump on this. So we have, and Dan also will share with you all the links in the chat. So, but remember, if you want, you can also join our community to continue this conversation there. Perfect. So for data sets, we will use the notebook number 1 and number 2. That is load ARI dataset and load deep lesion balance dataset. So we will have these two notebooks that we want to use. So the first thing that I invite you, I don't want to go deeper on that, but you need to create an environment, a Python environment, and you need to install the requirements that I have in this repository. With following these, you can replicate the work that I'm showing here today. So let's start. So when we are talking about data sets, we have the way to, okay, how 51 is working, what kind of data sets we are supporting. Let me start with this. So 51, we are talking about the open source solution, as simple as pip install 51. And depending of the complexity of your data set, you can load this in different ways. So you can use hub coming from Hugging Face. You can use the images coming from your directory locally. And you can also use the dataset zoo that we have. And finally, you need to have in mind that 51 has two ways to work. One is the 51 SDK, and the another is the 51 app. So 51 is really good to visualize data and try to showcase something that is maybe we are not catching, we haven't catch that before, and this is where we have a lot of tools around. So let me navigate two data sets that are complex, not normal. So I'm not talking about how we can load this data set from Hugging Face or how you can load this from the data set too. I'm making a little bit more complex exercise, but at any time, you can take a look of the documentation and see how these easy ways are working. So let's talk about ARI and deep lesion data sets. So we have two data sets for this specific steps in the workshop. So let's start with deep lesion, that I already mentioned this in the demo that I made before. Let me jump to my code. Okay, this is not the code that I want to show. So, okay, let me jump to my environment. So I have my environment. You can also run this on, Jupyter Notebooks, Jupyter Lab. I have VS Code. It's okay. So let me show you how this is working. Normally, when you have a data set, you have maybe a structure. You have the structure of the data set. You have maybe, for this specific data set that is ARI, so I will start with ARI. Let me show you what ARI means. Let's see, ARI is here. Okay, this is ARI data set. So we have an automatic region-based coronary artery disease diagnosis. This is a challenge. This is a challenge for the Mackay conference in 2023 that was, and also you can take a look of the Nature, the paper. Okay, something is not working here, but yes, the paper is here, so you can take a look of the paper as well. So we are using this as an example in how we can navigate this. So basically the data set, we are using the version final phase, and we have multiple folders, and the data set, the directory structure is also showing some tasks and phases of the data set. So I just want to have that in mind and point that out, because we will see how this is affecting the analysis. So we have phase 1 of the challenge, we have also final phase of the challenge, and so on. So we have also some specific segmentation training for some segments a part of stenosis. And we have stenosis as a specific classification or detection in the data set. So let me jump on that. Okay, let me jump on that. So this is what I have in the app. I can see here the segmentations. I have the labels I mentioned before. We have 26 segmentations here, and we have a stenosis. So we have also here something that we call phase. So we can see the phase of the challenge. We have final phase, we have phase one, we have the task. So what the task means? So normal segmentation or stenosis. So we have multiple information in the data set. We have also a subset name. In this case, we have, for example, if it's a trained portion of the data set or it's a validation portion from different momentums of the challenge. How this is working, I can see the output of the output of my code in Python. You can see also bounding boxes. You can see also here the segmentation mask, how we can digest that complex data set using 51. It's simple. So something that we need to have clear is what is the structure of your data set. You have a seg train, you have the path, you have a lot of information. The most important thing here is that you should create a data set. So in that case, so you need to call this, you need to call 51. So the first thing, you need to import 51 as FO. And then with that, we can create the data set. So basically, we create a data set called, I just put the name here. I'm not making anything else, just adding the name. That I add this name as ARI Combined. So I call this ARI Combined. This is the data set that I have. And I will start adding fields to my data set, phase, task, subname, everything, I can also add a lot of metadata and assign this metadata to the samples. What that means that to the sample, I will assign new metadata that is phase, new metadata that is task, and new metadata that is subset name. So with that, we are adding the samples to the data set that we create in 51, and that's all. Then we can just launch the app. And when we launch the app, we can see the GUI that I showed you here. It's simple. So, but the complexity for sure will depend on your study. If you are making a study and you have a patient index and you have, you have multiple folders, or you have, let's take a look of another example. So let's take a look of this example that I already mentioned, showing this as well. So where we have multiple information, we have a lot of metadata here. And the complexity of this deep lesion is, for deep lesion, we have, this is the introduction of deep lesion. So we have, it's a large scale data set. This data set has 32K axial CT slices. And it's a huge study with more than 4K patients in there. And the way to access this is through zip folders. So you need to unzip the folders. You need to understand what is the structure of this. So you need to read this documentation to go through it. But this is what we have. So we know we don't have a straightforward way to work with healthcare data sets. So let me show you how I'm managing this. So basically, we could access this data set from Hugging Face. So I just load the repository from the hub, and I needed to unzip all the folders because I have just zip folders there. And then I start looking for the metadata that the data set has. When I can see that, I need to pre-process the information, and I need to make like a DICON windowing. This is a really important task because we have, in this case, we have just images. We don't have CT scans, so the data set itself has selected CT scan slices, and we need to visualize this much better. So we need to normalize the intensity to normalize this, to visualize this better. And then, moving forward, we are normalizing this, we are doing that. So, but we need to build a 51 data set from this deep lesion metadata that is huge. So, and this is the same way that we made for ARI. So we need to read all the documentation the metadata is coming from. We need to understand where the image root is, at least the root path. And then we need to start adding metadata. What metadata means? We need to add bounding boxes. We need to add this information that is also coming from the metadata that we have. And we need to add all this information, like I'm adding every single field to my samples. So this is the way that this is working with. And then we can launch the app and see what is going on. So let me show you is here. So this is the the devolution. We have the 32K samples that are reported in the paper in the README file, and we can access all the metadata. You can access this. We can also take a look of the data set. Do you have any questions? So Dan, we have any questions so far?
Yes, we have two in the chat if you want to take them now, or in the Q&A, I should say.
In the Q&A, okay. Okay, so I'm a data scientist who wants to pivot to health focus. If I want to look into what 51 offers to me as sandbox to learn and optimize, any recommendation for how should I jump in and start building without a health background? Okay, so something that is really important, we are simplifying the way to navigate data sets. We can also improve the data set quality. We can understand a lot of things with embeddings and all the features that we have with the 51 brain. But also something that is really important is we need to be responsible with that, because we need to have the expert in the loop. In this case, I'm not an expert in the loop. I don't know if this is a lesion. I don't know why this is a lesion, I think that depends of what you want to do, you can do that, but this is a serious, I think, ethical question that is raising, and I think that is important always to have experts in the loop. So 51 can help in these studies to navigate the data set improvement, but we need to be responsible on that. 51 will provide you a great way to understand data, but not all models are working on this specific industry. We can see, for example, that we have a lot of models trained right now with ImageNet, so we need to fine-tune those models to work with X-rays, and there are a lot of researchers working on that. So I will recommend to use the latest AI technologies. When you are using a model, you need to understand where the model is coming from, what kind of data set they are using to fine-tune the model or to create the model. That's all. Another question that we have here, what are the tools 51 has for cleaning up hyperspectral images? So I think that I will answer this during the workshop today. We are also supporting hyperspectral images, multiple channels of images. So let me move forward and continue with the chat, with the workshop.
Thank you, Paul.
Okay. Thank you, Dan. Okay, so let's move forward. We have this way. So if I go through my code, if I jump to my code and I in the ARI, for example, the notebook number 1, and I want to take a look of what the data set is, I can just print the data set and take a look. Okay, this is the name of my data set. What kind of media type I have there is image, how many samples I have, and all the sample fields that I have. I already add this, this is important. And we have something that we can do is really, really good. So basically with 51, we are pointing file paths, we are pointing metadata, we are adding that, we are creating like an unstructured data set. We sometimes need to come back to that, so we need to make that data set persistent. By default, data set persistent is false. That means if you turn off your environment or your computer, basically you will lose this data set. But if you make this persistent, you can come back to the data set and load the data set in a simple way, just calling the data set with the name. This is super important. So now let's take a look of what we have for, let me take a look of this. I just want to show you something here. Sorry if I'm moving this. Okay, here we have the print of the data set. So this is deletion. So we have 32K and all the sample fields that I already mentioned, This is important. It's also important to understand and what kind of information we have per sample. So we can also print, for example, I'm printing here the last sample of my data set. And what I have here is, just let me move this a little bit here. So I have the ID, I have this is an image, I have the file path, I have a tag. If I have a tag, so this is already something that I already add to my data set. I have all the attributes, the ground truth information, the detections. See, we have segmentation, we have the bounding box here, we have also the mask, if we have a mask or not. So we have the patient ID, index, and all the metadata that we already mentioned. But I want to put you also, focus on this because we will talk about this later today. I was adding more information to this data set. So I was adding embeddings, I was adding indexes to understand my data set, and maybe some metrics that I need to curate and filter my data set. So let me come back to the presentation. And we already talked about this. I think that this is clear how you can use the data set that you have locally. And talking about the 51 architecture, client server structure. So in the back end, we have the data set storage, we have the indexing part and the queries. In the front end, we have the visualization environment and the user interaction. This we can consider this like the 51 architecture. For the dataset types and format, as I mentioned before, we could add more metadata and fields to our samples. So we already, for example, you saw some sample field that it was called embeddings. It's because I already made a calculation of the embeddings and I add that field to my data set. So that makes that when I come back to that data set, I can open that easily and take a look of the embeddings. Same for deletion. So if we think about the data management structure of 51, we have four main things here. We have the sample metadata where we can see file paths, the dimensions, properties of the images. We have also annotations and labels. If we could have bounding boxes, segmentation masks, classification labels. We can also see embeddings and features that are more like some insights that we have from our data set, some calculations that we are doing, for example, to run similarity search or calculate feature vectors. And model predictions for sure, output of our models and evaluation matrix. So if we think about the hierarchy data set structure, we can think about the data set is a table, and the data set is a table, a collection of images, videos, or 3D point clouds. Each sample is a row when we have an individual image or video in data set. And each column is the field where basically we specific information about that specific sample. So as I showed you, when we print out this data set last, we can see all that information that help us to understand how this is working and what is the role of that specific image or those specific samples in our data set. So, and this is not just to understand the metadata, it's also understand some calculations or we are running models. So we can see, for example, if we have labels, how those labels are working, if it's segmentation, detection, or classification, we can also identify that in the printout of our sample. So let's move forward. We will continue using the notebook number 1 and number 2, and we will talk about how we can curate and filter our data sets. So let me jump to the notebook number 2, where basically, we have, I will show you what I want to show you here is this one. So deep lesion is a huge data set, 32K, large scale data set. So maybe I'm interested to train a model with one single lesion type for one specific range of age of my patients. And I need to create a balanced subset of this huge data set. How we can do that in 51? Is possible? Yes. So and this is an example. Also, you can run whatever you need for your needs. But this is the step-by-step. So basically, we have the lesion. We have the size of the lesion. So what I'm doing here is I'm computing the short axis diameter from my lesion. Then I'm filtering the lesions with a short diameter higher than 10 millimeters. And then I just list the unique lesion types. Just want to have 250 samples per lesion type in that specific size, higher than that. So I'm looking for huge lesions in my data set. And that's all. So how this is working. So basically with 51, we can view fields and we can filter. The first thing that we are doing is we are queuing the data. How we are queuing the data? With multiple ways, but one of the ways is create a match. So basically, so in this case, I just make a short function to calculate the short diameter of the lesions because I have basically 2 dimensions. So I need to calculate what is the shortest. And that's all. I create that specific metric and I add that metric to my data set. So then I set the value and I add the value to my data set. And then I just filter for lesions higher than 10 millimeters. So how this is working, I'm using this data set that match, and I'm using field view to say, hey, field view is short diameter, select all higher than 10 and make match in my filter view. This is super important, this concept of views. We can create views, basically subsets of our main data set that are matching with this specific rule. So then we can just take a look of the lesion types that we have. And finally, we are doing a similar thing to identify or create a new view that is matching in my filter view that is matching with the lesion type that I'm looking for. And I'm looking to have 250 samples per class. So basically here, I'm filtering my previous view. So we have 2 concepts, querying and filtering. And then, so basically, we can also tag. We can also include some tags to those specific data sets. So I can call, this view, the new view, I can call in a different way. I call this balance view. And I select all the IDs of my images that I have there. And I add these tags, balance subset. I will explain that shortly, what that means. And then I just launch the app and I can see what is going on there. So let me show you. Okay, what I have here is, that specific data set that I already have the balance view. This is the balance view with 2,161 samples. And I have here the tags. So I can make this for the general data set. So where I can mark some images or some samples with one specific tag. We can call that like a pre-annotation or maybe human in the loop that we can tag if this is something is good, something is not good. So we can also make that interactively with the app. And so basically here we have the lesion, and all the lesions that you will see here are big lesions, are not small. And we have a balanced data set. So how we can check if this is a balanced data set? So we can take a look of the dashboard. And remember, this is a interactive plot where basically I want to create maybe categorical histogram. Let's see. Let's see. Let's see if we can see tags. Okay, no. Let me see. I think. Oh yes. So let me add numerical histogram, and I will add lesion type. And as you see, I'm trying to create a balanced data set with lesion types. What happened here? So the thing here is that we don't have for bones, this is the number one. The number one lesion is let me create this plot. The number one lesion is our bones, and the less count of my original data set. So for that reason, I don't get the top of 250. So for the rest, we got that, and we have a balanced data set. So we can take a look of that on that way. Okay, let's move forward, and let me just recap. I love to make this recap, so you already pay attention to what was going on in the code. Let me recap. So remember that we were making querying and filtering here, where basically the first step was the querying, and the second step here was the filtering. So we have two ways to manipulate data in 51. We have these two ways to query and filter the data set. So basically, the first one is the query. It used to retrieve specific samples that match a condition for the entire data set. And the filtering is that using an existing data set view that is already refining as an output of the query, I'm removing unwanted samples, or I'm adding more, or I'm just selecting some of those. So this is the way that 51 is manipulating the data. So let's recap also in something that is important. We have the original data set with all data. We can see views as a temporary filtered data subset. But this is temporary, is something that we can lose if we don't export or clone. So maybe I need to export that data set to send that back to my training process. So, and I need to clone. And this is the way that we are subsetting the data set. So I already have the balanced data set that I showed you in the view. I have this balanced view. I clone the view, and I call this div lesion balanced. I clone the data set, and I can export this with multiple formats. So for example, I want to have this in 51 format, so I can export, but I need this in Coco, I need this in YOLO, I need this, we are supporting everything. So you can export that in multiple formats if your training pipeline needs specific formats. So, okay, I think that it's time for a trivia question. So the fastest, what is the lesion type with less counts? The faster person in the chat will win a swag. So let's see if they are paying attention. So you remember what I mentioned before? You can also make your bet. So what is the lesion type with less counts? So, and the person with the right answer will win a swag. Okay, if we don't have answers, I already mentioned the type. I already mentioned the name of the lesion, because here we can see just the numbers, but I mentioned the name of the lesions. So I think that we can make this next time. Pay attention, because maybe another trivia question is coming. Okay, let's move forward. Let's talk about 51 brain. This is super important. With 51 brain, we can explore embeddings and different kind of indexes that could help us to gain insights in our data set. So if you are familiar with what embeddings are, basically embeddings are an image to insight transformation. We can convert the image in a high dimensionality vector or high dimensional vector, when basically we have multiple features, and those vectors could be super long, a lot of cells, a lot of columns on those vectors. We need to have the way to reduce the dimensionality of those vectors in order to visualize what is the relation. So the good thing is, when we are converting the images to embeddings, because we are running a model and we can calculate those feature vectors, when we run the dimensionality reduction, we need to preserve the relationships in between those features in that vector. And then we can visualize and cluster with similar images. So 51 has an engine to work with embeddings. We can visualize embeddings, but also using embeddings, we can calculate the similarity index. We can calculate leaky splits. We can calculate near duplicity. We can calculate uniqueness, representativeness. So we can also calculate a lot of stuff there to understand different kind of momentums of our data set, not just the raw data, but also what is going on with annotation. We can also take a look if we have a mistake in the annotation process, or if we have a problem in our modeling production. So let's take a look of this. So we have two ways to work here. So we can calculate embeddings for images and image level. So where basically what we need to do is we need to call the first thing that we need to call is 51 brain. This is the engine that I'm talking about. And we need to call compute visualization. When we are making this, what is happening behind scenes is 51 is calculating embeddings using default model that is CLIP, and it's also making the dimensionality reduction with UMAP, but you can select different methods for the calculation of the dimensionality reduction, and also you can use a different model for the calculate the embeddings. There is another function that is called compute embeddings instead of compute visualization, where basically you can calculate the embeddings first, and then you can call compute visualization, calling the embeddings field that you are adding in your samples. This is one way to work. We are working at this at the level of data set of the images. But if I have patches as I have in the ARI dataset, so basically what I can see is I have some bounding boxes with some specific information. I can compute the embeddings of those patches and understand how those patches are correlated to each other, computing the patch embeddings. So in this case, I'm calling a model from the model zoo that 51 has, that we will talk that in shortly. And I'm also adding this patch field called segmentation. That is the field that I have in the original data set. And I'm calling this model, and I'm adding embeddings field equals patches embedding to my data set. And then the first step is calculate the embeddings for the patches. And then I can compute those, I can visualize those patches in the panel. So how? I need to identify the patches field, and I need to see what is the patch embeddings field that I'm talking about here regarding this one. So I will jump in the demo that we have for that. So basically this is start this from scratch. So remember that we have the images that we already compute the patches. When we compute the patches, we are able to do this. If we haven't computed the patches, we are not able to see this option in the GUI. So I already compute the patches. I know that my patches are here. I can click here and visualize all the patches that I have, everything, with no restriction. I just restrict this here to just take a look of the stenosis and see what is going on with the stenosis. And then I can visualize the embeddings coming from the patch embeddings. If I click here, I will see the embeddings of image level, but let me click here. And this is really good because you can understand, for example, something that is important maybe is the orientation of the stenosis or the size of the stenosis, and we can take a look of that. So with embeddings, and these embeddings for sure are totally different of the embeddings that we have at image level. So let me show you to what we have at image level. So these are the image levels. So let me go to embeddings again, and I will change my brain key. This is super important, is the brain key. How I'm calling this in the SDK to cross-relate this in the app, in the GUI. So I'm clicking here, and as you can see, we have multiple clusters, and those clusters are related directly with the face or with the task of my data set. Do you remember that ARI is coming from a challenge? So we have multiple phases, and it seems that this is sensible to the task, the momentum in the challenge. So normally, for example, if you have CT scans or something like that, we can see those embeddings and clusters per manufacturer, for example. Depend of the model that you are running. So in this case, we are running a clip model that is the default model. So you can take a look of the embeddings, and there are multiple things to do with embeddings. But let me jump in another example with deep lesion. I think yes, this one, where also we have the embeddings, but we already can do also calculation of sub-indexes that are important. So for example, here with deep lesion, I already calculate the uniqueness. So I can open the uniqueness index and see on the embeddings what kind of unique images I have. And I also can go through the GUI in the metadata and select uniqueness and find a value, for example, in between 0.7 to 1. So let's see. And I'm using both, I'm filtering with this and I'm filtering with this. So I have the uniqueness, and you can see where are the unique images on my data set. So I can take a look of this, for example, outliner, and take a look of what is going on with these specific samples. So those for sure are unique in the data set. With a high value in the uniqueness. Go ahead, Dan. Okay, do we have questions? Yes.
Yeah, we have one question in Q&A if you want to answer it.
Okay, do we use or plan to use synthetic data in such medical use cases specifically to address rare scenarios or conditions? Yes, for sure. This is something that also we are looking to implement in 51. We can also work on that. So we can see more efforts coming from companies as NVIDIA with Omniverse and Monet project, that they are trying to create more scientific information because the privacy is a huge deal in healthcare. So I think that this is super important, and yes, so we can address that as well. And we have another question. If we have an annotated data set, can we use image embeddings together with 51 engine to identify similarities between scans in order to organize them, folders or groups? Yes, totally yes. So something that we can run also in 51 is you can use some plugins, and I will talk about that shortly, where you can also run, for example, clustering. You can use Scalearn. It's just 10 lines of code. But if you have this, if you have this as a plugin, the clustering process will be straightforward. Okay, so can we also work with biosignals? If the biosignal is part of the metadata, I will say yes. But we are not working right now with time series. So we need to manage that information in a way to add that biosignal to the image and analyze that biosignal in a different way. But yes, it's possible as well. Okay, let's move forward. And I already create here some videos, but it's just for you to take a look of this after the workshop, because I already showed this in the real demo. So let's talk about Model Zoo. So I think that this is one of the most impressive features that we have, where basically, because in 51, you can take a look of your data sets, you can take a look of your, the quality of your data set. But You can apply models. You can apply also models to annotate. You can apply models to pre-annotate. You can add models to understand your data set. And models now are growing and growing. So every week we can see a lot of new models in the field. We have a great feature. We have a standardized interface that unifies the model interaction with 51. So this 51 Model Zoo provides a native access to hundreds of pre-trained models in the Model Zoo. And it also supports downloading arbitrary public or private models if we already have the definition on GitHub repositories or specific URLs. So at this time, we will move to another two notebooks, the Notebook 5 and Notebook 3. And so we will talk about that, and we can see how that is working. So basically for the Model Zoo, we have hundreds of ready to use AI models. So if you're looking to apply YOLO to your data set and YOLO is there, you can apply. If you want to use, and we will talk about that, MedSAM 2 is there, and you can apply MedSAM 2 to start pre-annotating your data with some prompt bonding boxes that you have. Also, we are supporting video, and this is really good. We can also integrate models from GitHub and other URLs, where basically we have this remotely sourced zoo model. And we have a seamless model integration with these three things. And let's start with the first one. I already mentioned that we have support for MedSAM 2. If you are familiar with SAM 2, so MedSAM 2 is a fine-tuned model for medical images, videos, because SAM 2 has also the possibility to analyze the video frame by frame, and we can estimate in the next frame where the segmentation with bounding box is coming from. It is going to. So in this case, we can load this data set from the hub, and we can load this model from the zoo, that is MedSAM 2 Video Torch. Something that is really important to understand, you need to install SAM 2, in the SAM 2 repository, you need to install where you are running this. That is important. That is also a detail that I added in the notebook number 5. And then as simple as call the data set and apply model. So basically, when you call this is part of the API that we have for models for the model zoo. So apply model, you need to call the model, you need to add what is the new label that you want to add in your data set, that in this case will be PRED segmentation. And then you need to prompt your model with some ground truth detections that you have. So what that means, that if you have a small amount of annotations, you can use that small amount of annotations as a ground truth detections to prompt your data set and find more labels that could find maybe a liver or a lung or a arteria, whatever you have in your previous in your original data set. So let's jump on. Give me one second. Let's jump to the demo here. So we're basically, okay, let me show you first the notebook. So I already showed you we are loading this data set that is the VT-CV-CT as video, MedSAM 2. Is also in the Voxel 51 hub. So we are using, in this case, we are using the Hugging Face integration that we have from loading, this data set from the hub that we have in Hugging Face. So in this case, we are, just taking some frames from the data set, and we need to install and validate SAM package. So I already put some instructions because in the latest releases there are some problems with setup tools. And then you need to apply SAM 2 video to your data set. So in this case, I'm prompting the field with all the detections that we have. But, let me show you this in the app. So So what we have here, so in the app, so what we have here in the app is we have frames, ground truth detections, and we have also frames from the MedSAM 2. For this specific demo, I was prompting the data set with liver information. And what the model is doing is detecting liver in every single frame in the video. Maybe there are some errors because I don't believe that this is a liver. I'm not an expert, but I think that the liver is on our side. But this is part of the responsible stuff that we need to take. So we are empowering you to use 51, and you need to see how you can navigate this as well, because you need to fix this problem. This is a problem that we can see with the model, how we can fix this. So we need to eliminate these annotations that are wrong, and we can take a look at that with the model evaluation. So this is MedSAM 2 coming from the model. So what happened with the another possibility with remotely sourced submodels? So imagine that instead of being built in, you have a model that you want to use in 51, and that should be straightforward, and is hosted somewhere you have the URL, you have the repository. We have a video here from a repository from our colleague Harpreet, that he is creating a lot of, implementing a lot of VLMs and creating these remotely sourced models from his repository. And so let me explain you how this is working. So basically what we need to do is we need to have a manifest JSON file, where this manifest JSON file is basically setting up the model in 51. Then I need to add an init py file where I need to showcase to the API how I want to download the model, how I want to load the model. I need to showcase those capabilities. If the model is complex, so we need to add more stuff, for example, in the SU-py, where we have the embeddings, when we have maybe a similarity search index as well. So we need to have that in the model. And basically we are using this is NVIDIA Labs C Radio, and this could help us to see spatial spatial temporal information of the images, like an explainability or saliency map. Let me show how this is working in the code. And so this is the notebook number 3. So basically this is a visual foundation model. And so what we are doing is, after we run the notebook number 1, we already have this ARI dataset in 51, and you can download right now this from the Hugging Face hub, and it's straightforward. And then the thing that you need to do when you are downloading this, so you need to split this in train or validation. So basically you can run train, and then you need to register the model. So the first thing that you need to do is you need to register the model with the API that we have for the model SU with the URL. And then you can just load the SU model as a built-in model. And then you can, make the rest similar that we have been doing in the past, with compute embeddings, compute visualization. We can calculate uniqueness. For example, we can calculate similarity, we can calculate uniqueness, we can calculate representativeness. So this is because the model is also supporting those indexes. This is super important. Not all models will allow you to calculate embeddings or similarity. So this is something that you need also to set up in the URL. So, and this, I will consider this like a little recap of what we have been talking about today. And so let's review those concepts, because we have, you have this data set, right? ARI with the 51 format. And I already include the C radio, that is the visual foundation model, so where I can see saliency maps on that. So as you can see, we have some errors here. So something that is important is this C radio model was trained with ImageNet. and we are using medical images. So maybe we need to fine tune the model to see a real saliency map or special features of our data set. But this is a really good example of how we can move forward things, and maybe also we can take a look of embeddings coming from this model. And I'm taking this as a recap, but this is coming from a data set, from a model that is in the remote source model. So, and we have here the embeddings coming from this data set, and we can also see if we have the uniqueness, and we can identify the most unique and the most representative images in the data set. And it's what we made in this notebook. We are also running a filter and curing process as a recap to identify the most unique images in the field. So for why we need to have this, let me explain you. So it's here. So here, so we have, the stenosis view. I'm just matching the task with stenosis. All samples that are marked with stenosis, I just want to have a view of that. And then I want to set up all the the most unique and the most representative values in the images. And I want to set up a small data set for fine tuning a YOLO model. This is part of what we are also looking for here. So we are trying to create a top 300 images for YOLO fine tuning. So I'm calling this as a recap. You can take a look of the notebook, and I will move forward with the workshop. So what we can do with that subset of 300 images in ARI. So what we can do is we can fine tune the model. We have a lot of integrations. We have an ultralytics integration where basically you can call the model from ultralytics and you can apply the model with the API that we have for models. So you can just call the model from ultralytics and apply the model directly with the 51. And this is possible because of the integration that we have. You can scan this QR code to access the notebook number 4. And then when we already have, you can apply this, but you can take a look of the results. Those are terrible. But we need to fine tune the model. How we can fine tune the model? Using the CLI from ultralytics. So we can fine tune the model with the subset that we already create. And also we can run the inference to calculate the predictions over the validation data set. So what we have here is the way to put together the predictions and the previous annotations. So basically you can take a look of those, We have the ground truth and we have the predictions. So the semantic segmentation is another model that we have there, but just be focused on the bounding boxes. We can also run the model evaluation panel. Once you calculate when you have the evaluation key that we call, you can open that evaluation key and you can take a look of the model evaluation. And as we have been doing for the dashboard and embeddings with the interactive plot, you are able to navigate this plot and take a look of the false positives. What is going on with the false positives? Where my model is failing? What kind of information I'm missing? All of these questions. So are possible because we also have the model evaluation panel that you can navigate. You can take a look of different metrics in the evaluation system. So you can evaluate not just detections, also classification and segmentations. And this is a really good way to cross the loop and the feedback from your model before the model hits in production. So let's move forward with the integrations and plugins. So I think that you are familiar with this image where basically we are feeding for data quality, model evaluation, and also annotation, because right now we have the way to verify the auto labeling, having the human in the loop. So basically we have two options to work. So we have the open source solution. This is something that the platform that I have been showing today is the open source, but also we have the enterprise. If you are a single user, you have local data, and you want to have individual experimentation, the open source solution is for you. But if you have multiple user collaboration, billions of samples to analyze, MLOps orchestration, you need to move forward with the enterprise. Also, something that is really important for the healthcare is the security and complaints. So in that case, think about enterprise as a solution as well. So in that case, we need to talk about the integrations, and when we have this, this integration in the enterprise are really straightforward. So for the open source, we need to think that we have integrations for visualization, annotation, storage, curation. We have multiple partners that are working with us, and we are also working with open source solutions to integrate those pipelines in 51. So one of the main features that makes 51 shines is that we have a lot of flexibility. So you have, if you have your PyTorch pipeline for training, you can include that here with no issues, and with Ultralytics is a great example, for how we can connect with Ultralytics. We have also, we can augment data as well. We can call annotation tools as well. Okay, but let me explain you this. How we can work with 51 and how we can make those integrations. So we have like a 51 extensions where basically we have integrations that connect 51 to tools outside of the app. And we have plugins like add new tools inside of the app. So how this is working, I will show you. So we have a repository where you can see all of the plugins that we have. Native plugins from 51 and plugins coming from the community. So this is really, really important. We have native plugins like annotation, brain, dashboard, evaluation. And we have plugins coming from the community, for example, like quality, image quality, or we have some integrations with different kind of VLMs. You need to take a look of this web page and this repository, and you will surprise. And I invite you, as a community member, if you want to be part of this community, we are doing a lot of stuff. If you have your own code and you want to run this on 51, you can create a plugin and you can share this with others. So, and this is one example that we have, and this is coming from the community. Adonai Vera, that now is our colleague. So he created this plugin with a visualizer of OHIF, where basically you can visualize DICOM images, DICOM format, and play with that. So there are a lot of things to contribute. So it's possible maybe to contribute to this one, to communicate directly with 51 and send back some slices to 51 to analyze those running a model, for example. So we have different ways to contribute on that. So when we have 51 plugins, we need to identify two things. We have operators versus panels, and we have the operator basically is a functional block, and the panel is an interactive space. So imagine that the operator is the back end of the panel. The panel is what I can see, and the operator is what is going on behind scenes. So operator will execute tasks, and also will take some input, logic, and output, and perform some actions. And the panel will visualize and interact with the users. And basically, it consumes the operator results and also can send that some information to the operator. So if you want to create a plugin, I think that you need to have clear what kind of code, what kind of software do you need inside of 51. It's straightforward. And also you can take a look of this documentation, but basically it's having clear what is the main function that you want to run with the operator. So we are also supporting complex pipelines. So I will invite you to follow the notebook 6, notebook 7, and notebook 8. So for those notebooks, we have, some requirements. So for example, this Vista 3D demo, Vista 3D is one of the NVIDIA's foundation models for medical imaging. So this is capable of high quality 3D segmentation across a variety of CT scans. And we are running this demo on the total segmentator 50 dataset which contains CT scans from multiple institutions, patient demographics, and equipment manufacturers. So the demo shows how 51 can support heavy models like NVIDIA Vista 3D as part of the full annotation pipeline. So rich metadata support and also segmentation at scale. So we can automatically annotate entire scans across organs and pathologies using a single inference step within 51. And we can also use embeddings for comparative analysis, visualizing patient clusters or comparing inflammation patterns across demographics. So we can do that as well. So we have another demo. I think that I'm almost done, so please stay here. I'm almost done with this. So where basically we have Med-Gemma and Med-Cyclip. Those are both AI models releases by Google as part of the Health AI Developer Foundation, and designed to accelerate healthcare and life science AI development. They are both considering strong starting points for medical research and product development. So the primary function is Med-Gemma is a generative model for both medical text and images comprehension, capable of producing free text like reports or answers. And Med-Cyclip is a specialized image and text encoder that creates some tasks like classification and search without generating free text. So let me see if I can show you. This is Med-Gemma. So let me show you this. So for example, and you can navigate this report, the notebook that we have for Med-Gemma. Let me show you what is that. So Med-Gemma is here. So where basically we have here, and this is also coming from her Prince repository, but also you can take a look of this notebook in the repository of this workshop, where basically we are loading the data set and we are making some questions about how we can classify these. We are using Med-Gemma and we are registering the model because we are using this as a remotely sourced submodel. We are downloading the model, and we are load this from the zoo. So if you have a NVIDIA GPU, you can put this quantized true. Otherwise, you need to put this false. And you have the way to classify with Med-Gemma and add, new predictions to the data set. You can also make some Q&A to the data set. And also classify some images. Let me show you how that is working. So basically we have multiple ways here. We have multiple type of images, dermatologists, reports, and everything. So for example, here we have the prediction for the body system this is dermatology, or the Med-Gemma classification as well. This is a redness of the skin. So if we move to another one, so for example, this is a radiologist of food, and this is a skeletal. So imagine that you have, and this is maybe a question that is in the chat, is if we have a data set that we don't have annotation, so maybe we need to define which X-rays are from chest or foot or brain, and we can classify this as the first touch for annotation. So we can use these kind of models to do that. And for let me show you. The another one is Med-Cyclip, where basically you can calculate similarity of those images. This is image retrieval now, and I think that we need to work a little bit more in the zero-shot classification with this model, but this is working pretty well for image retrieval. You can take a look of the notebooks you can also run this on your site. And also take a look of the videos that I have here. So let me just wrap up. I'm super conscious about that. Your time is super important. I want just to grab this, talking about the benefits that we have with 51. We have a time efficient way to create a better AI. The cost reduction that we have, because we can reduce the expenses for, a better financial management. We can improve the accuracy of our models, and for sure we can enhance the answer of our system. Finally, we can see a coherent visual AI platform that is created by Voxel 51. And Voxel 51 is the team of lead maintainers. So we are the lead maintainers of the open source 51 toolset and we are making a visual AI a reality. So please, what is next? Easy to do. Pip install 51. No subscription, nothing. So just pip install 51. Try the dataset that you have in mind. Try the data models that you have in mind. You can also try our tutorial page, join our community, and attend our events.